In the final section of Architectural Styles lesson, we will dive into microkernel architecture style. The microkernel architecture style, also referred to as the plug-in architecture, was coined several decades ago and is still widely used today. This architecture style is a natural fit for product-based applications, packaged and made available for download and installation as a single, monolithic deployment, typically installed on the custom RER site as a third-party product, but is widely used in many non-product custom business applications as well. The microkernel architecture style is a relatively simple monolithic architecture consisting of two architecture components, a core system and plug-in components. Application logic is divided between independent plug-in components and the basic core system, providing extensibility, adaptability, and isolation of application features and custom processing logic. One of widely used system that leverages microkernel architecture is Integrated Development Environment, IDE, where the core system is text editor. You can open a file, change some text, and save the file. Then, depend on each user's purposes, they can add plugins for customization at their disposal. Regarding to core system, depending on the size and complexity, the core system can be implemented as a layered architecture or separately deployed domain services as illustration. A separate user interface can also be implemented as a microkernel architecture style which can be deployed in single or multi-units. Plug-in components are standalone, independent components that contain specialized processing, additional features, and custom code meant to enhance or extend the core system. Additionally, they can be used to isolate highly volatile code, creating better maintainability and testability within the application. Ideally, plug-in components should be independent of each other and have no dependencies between them. The communication between the plug-in components and the core system is generally point-to-point, meaning the pipe that connects the plug-in to the core system is usually a method invocation or function call to the entry-point class of the plug-in component. And can be runtime-based. Plug-in components can be added or removed at runtime without having to redeploy the core system or other plugins. Compile-based, much simpler to manage but require the entire monolithic application to be redeployed when modified, added, or removed. Plug-in components can be implemented as shared libraries, such as a JR, DLL, or gem, package names in Java, or namespaces in C# as illustrated in the left figure, or runtime plugin components are usually managed through frameworks such as Open Service Gateway Initiative, OSGI, for Java, Penrose, Java, Jigsaw, Java, or Prism.NET, as illustrated in the right figure. Now student, let's search and compare frameworks. Open Service Gateway Initiative, OSGI, for Java, Penrose, Java, Jigsaw, Java, or Prism.NET. Plug-in components do not always have to be point-to-point communication with the core system. Other alternatives exist, including using REST or messaging as a means to invoke plugin functionality, with each plugin being a standalone service, or maybe even a microservice. Although, note that this topology is still only a single architecture quantum due to the monolithic core system. Every request must first go through the core system to get to the plugin service. It is not a common practice for plug-in components to connect directly to a centrally shared database. Rather, the core system takes on this responsibility, passing whatever data is needed into each plugin. The primary reason for this practice is decoupling. Making a database change should only impact the core system, not the plugin components. That said, plugins can have their own separate data stores only accessible to that plugin. For example, each electronic device assessment plugin in the electronic recycling system example can have its own simple database or rules engine containing all of the specific assessment rules for each product. The data store owned by the plugin component can be external or it could be embedded as part of the plugin component or monolithic deployment, as in the case of an in-memory or embedded database. The core system needs to know about which plugin modules are available and how to get to them. One common way of implementing this is through a plugin registry. This registry contains information about each plugin module, including things like its name, data contract, and remote access protocol details, depending on how the plugin is connected to the core system. The registry can be as simple as an internal map structure owned by the core system containing a key and the plugin component reference, or it can be as complex as a registry and discovery tool either embedded within the core system or deployed externally, such as Apache Zookeeper or Console. Using the electronics recycling example, the following Java code implements a simple registry within the core system, showing a point-to-point entry, a messaging entry, and a RESTful entry example. The contracts between the plugin components and the core system are usually standardized across a domain of plugin components and include behavior, input data, and output data returned from the plugin component. Custom contracts are typically found in situations where plugin components are developed by a third party where you have no control over the contract used by the plugin. In such cases, it is common to create an adapter between the plugin contract and your standard contract. Plugin contracts can be implemented in XML, JSON, or even objects passed back and forth between the plugin and the core system. For example, regarding to architecture characteristics ratings, similar to the layered architecture style, simplicity and overall cost are the main strengths of the microkernel architecture style, and scalability, fault tolerance, and extensibility its main weaknesses. LSO, like the layered architecture style, the number of quanta is always singular, 1, because all requests must go through the core system to get to independent plugin components. That's where the similarities end. The microkernel architecture style is unique in that it is the only architecture style that can be both domain partitioned and technically partitioned. While most microkernel architectures are technically partitioned, the domain partitioning aspect comes about mostly through a strong domain-to-architecture isomorphism. Testability, deployability, and reliability rate a little above average, 3 stars, primarily because functionality can be isolated to independent plugin components. Modularity and extensibility also rate a little above average. With the microkernel architecture style, additional functionality can be added, removed, and changed through independent, self-contained plugin components. Performance is also 3 stars because microkernel applications are generally small.